Hi, everyone. It's great to have you. I will be showing something that might look very basic, but I hope to include some steps that even if you've already reproduced a study, might be things that you might not have carefully thought about before. But because I get to reproduce hundreds of papers every year, I have to think about a lot. Before we jump into things, could I just have a show of hands on Zoom, like who is completely new to reproducing studies? Okay, looks like nobody's entirely new, which is good. So there shouldn't be too many dramatic surprises. So let me start by sharing my screen and showing you the study that I picked for today. I've already pre-tested everything, so it should run. If you want to follow along on your second screen, absolutely go for it. So let's go. So the study that I picked for today is about unlocking young women's potential, the impact of a low-cost career guidance program. It's from the Journal of Development Economics, and you can see it's February 2026. It's as fresh as it gets. I really like the study. It's about basically looking at girls and their planning for future. And because it's a randomized control trial, in terms of analysis, it's relatively straightforward. So you have found a paper that you want to reproduce. Now what? So the first thing you would want to do is to look for the replication package, so the place where the paper would have its data and code. Now, sometimes you're lucky and it will be directly on the journal website. This will be the case here. So I can just scroll right over here and I see data availability and I see exactly where the data and code are available. There's a link and the link isn't broken. Now, sometimes your life is not that easy and you have to do a bit more. So what can you do? So if the package is not on the journal website, sometimes you're lucky on the personal websites of the authors of the article. So I would recommend definitely starting there. If you don't find anything on their personal websites, you can look at the university repositories from the universities of the authors. So at least in some countries, there's an increased push for open science. And so if you work at a specific institution, that institution might require internally that you deposit all your data in a specific university-provided repository. So that's also a pretty good guess. Now, if that fails as well, I have had quite a lot of success with just unleashing AI and saying, look, this is the name of the paper, these are the authors, find me the replication package. And sometimes that gives you personal GitHubs or Dropboxes, these kinds of like places that might not be directly linked, but there is enough metadata floating around such that AI can find it. If that fails, you can also, of course, try contacting the authors. In my experience, if the authors have already taken the steps not to share anything, if you send an email, they might not be still willing to share stuff. But you can always give it a try. So, with all that said, is there something new in the chat? No. Good. Let's have a look at the repository. So we click on the link where this stuff is. We see a very nice repository on OSF, which is pretty common. We have the wiki, which is giving us some more information. So let's have a look. Let's read more. And an important part of this is the overview, which is telling you what is available. And the first thing I would look for is what kind of data is there. And well, this indicates that, okay, so we have some sort of a data set which is available. Great. I also see a note that there are some variables that are not included. So, okay, that's telling me I do not have the raw data the way it was collected. And I see that if I wanted these, I would have to request them. But for today, we're just working with what we got. So there should be a data set. Then I see, okay, so there's some sort of replication code, and there's a master do file that runs everything. Excellent. So that makes it very clear that the software that is being used is Stata, and there's just one file I need to run, and in principle, if I run that, I'm all good. I also have a contact email for questions. Excellent. So then I can go into the files, and I see that everything over here is available. There's a README and all the folders that I need. I've already tried it. I've opened the README. The README is just the same as the project description, so we don't have to go there further. There's no more information in this README. So we would download this as a zip. I've already done that to speed things up. This is the opened zip folder. You see that I have here the data, the do files. the README and everything else. So I need the code. So I look into the code and I see a master-do file. Now it's super tempting to just, go into the master-do file and press play. But before we do that, I still would like to stop for just a second and just verify what's in the data. And I see, all right, there seems to be a clean data set that was advertised. There seem to be some other data sets. That's fine. I would encourage you, if you can, to just generally try to open the data first before you do anything else and just look at what is in the data set. So just browse. So there's some sort of a student ID, and it's just, numbers in the order the students come. And then there's a bunch of other variables. And I find it useful to just scroll through and see. It's not just so that I know what is roughly in the data set, but there's one specific thing that I'm looking for. So far, we're looking at a package that is promising that there's data and there's code, and those are there. And that's great. But what I'm slightly concerned about is because it's an experiment, there might be data that might be identifiable, and that data should not be shared. Now, the description told us that some variables have been withheld. So that's a really good sign. But let's try to make sure that the authors have not forgotten anything. The reason why I'm concerned is because I have seen lots of replication packages where people forget that they should not share things such as addresses, IP addresses, bank account information, names, and other sensitive and personal data that should not appear in replication packages. And so just by scrolling, before I do anything, I'm trying to verify, are there any variables that look suspicious, that look like phone numbers, that look like addresses, that look like something that shouldn't be there? If not, that's fine. If I see something that's suspicious, I would need to dig in a bit further and take action, because what we don't want as replicators is there being publicly available data sets leaking people's private information. So in that case, we would want to take action. So data is looking good. I will close this for now. I will go back into the code folder and try running the master-do file. So I open the master-do file, and one thing I need to do is to configure the path. I've already done this in advance. So I've just, told the computer where I've stored the replication package. I wasn't given any other instructions of what else to do, but in principle, everything should run. And so I just run the file. Okay, something could not be opened, something isn't found. I would need to go and fix that. So this leads me to a point on debugging. So there's a big chance that the README file does not give you all the required information that you need. So sometimes the README file tells you, okay, so you should run this main file. You should change the path of that it relies on to read all the files. But sometimes there are additional commands that might need to be commented out. There might be things that need to be installed. There might be manual adjustments to the structure of the folders that you have to adjust. And so this debugging phase typically takes the longest. In this debugging phase, there's a lot of different things that are quite common, such as you might have to rename some variables, that somebody was initially using a variable called income, and they realized, oh, this is just badly coded. So then they created income fixed, but they forgot to change the naming in all the files. And so at some point in the procedure, it might break. So there will be your debugging. Expect this to happen for the most studies that you're reproducing. When you get stuck in the debugging and there is something unusual, so for example, it seems like part of the code is missing, what I would recommend is that you leave the code and you go back into the package and you try to see, are there any other materials in the package that can help me? So sometimes it is the pre-analysis plan, sometimes it is an online appendix, sometimes it's other documentation that people share. This is often very useful if the authors forgot to include, say, a part of the cleaning code of the study. because maybe the online appendix is actually describing in detail of how they create some variables or how they merge different data sets. So you might recall, if we go back to the repository, in the description, we had a link to the pre-analysis plan. And so that's really useful. So if there was something wrong with the creation of the variables, this is where we could go to double check what was the intention and try to backward induct from that point and bring it into the code. So that should help with the debugging. It might, of course, be that you encounter a study that is, so to speak, completely broken, that there is nothing you can do because there's not enough documentation, the code is broken, and you can't figure out how to fix it. That sometimes happens. My recommendation would be, in that case, just gather everything you've gotten up until that point and send it to the original authors and say, look, I'm really interested in your paper. This is what I found so far. Can you please help me get to the results? Right? The more detailed you are in what is breaking, the better the chance that they can help you out. Now, suppose that things are not broken. Suppose that you run the code, you get all the tables that you need, you get all the figures that you need, and you can then compare them with the paper. Does that mean that you have succeeded? Well, it depends. So it's often difficult to compare the results because the results in the paper are reported with finite precision. And when you rerun the code, there might be some computer differences in a sense of that a Mac and a Windows might produce slightly different results with rounding, or if you're running something in a different software, there might also be slight differences. And so it is then up to you as a replicator to decide, given what has been produced and given what is in the paper, is there a meaningful difference between these results? That will, again, depend on the paper and on the context. Sometimes it's completely reasonable that you cannot get out the exact results, but you should be within some sort of band of what is reasonable. I would encourage you to think about, are there implications for the conclusions of the study, given the differences that you found? So sometimes it really doesn't matter if the magnitude of the coefficient is 1.1 or 1.2, but in some contexts that can be very, very important. And so this should be something that is decided on a paper-by-paper basis rather than in general. So this should hopefully wrap up the experience of how reproduction of a paper goes. If you're starting and you have not done too many of these reproductions, I would encourage you to work as part of a team first. So have other people who are proficient in the relevant software and who are familiar with the methods that are used in the paper so that you can help each other. It is very useful to have just multiple pairs of eyes to look at something, and maybe you are not familiar with the specific error that pops up in the code, because sometimes it's just a matter of commenting out an extra line that shouldn't be there, but sometimes it's much more involved. And so having multiple experienced programmers together is very, very helpful. If you don't have a team and you want to start reproducing studies, you can just hang out with the Institute for Replication where I'm based. We organize these replication games. There's roughly an event every month all around the world where you can sign up and, as part of a team of researchers, do these reproductions of studies. You will get guidance from us, and you will then be able to write a report and even submit to a journal as a comment if you find that important. I think I'll stop here, at least for now, and I'm open to questions.